All right, so inequalities. Inequalities are your less than, greater than, all those different symbols. We'll write them down right here so we have them. Okay, so you got less than, you got less than or equal to, we got greater than, and greater than or equal to. I probably won't be able to think of like all the words right now. I need to pull up a list, but like we can Google a list too. Less than or equal to, like the things they say right here is like at most. Okay, so like at most would be less than or equal to. This would be at least. If it's at least, then it's going to be any number greater than or equal to that number. Well, if we find some more words as we're doing problems right here, we'll come up and add them though. But those are the two hard ones, I feel like. The at most is always less than or equal to, and at least is greater than or equal to. All right, translate the sentence x is at least 5 into an inequality. So that's what I just said right there. So you have x is at least, so that's greater than or equal to 5. It's at least 5, or it could be more. Okay. Y is less than 12. That one, they start us off easy here. Y is less than 12, so you do the less than symbol 12. It is not less than or equal to. That means it doesn't equal 12. It goes up to 12. So Y is less than 12. So when we're talking about, here's one we can add to our list. The number of books is more than 10. So more than 10, it will tell you what variable to use usually. So I'm going to use B for books, and it says more than 10. So that's just going to be greater than 10. So just think in your head, if it's more than 10, it could be 11. It's not going to equal 10. So it's just greater than 10. So more than, we'll go ahead and add that to our list up here. So this is more than. Okay, I guess in the opposite of that, we could change this one to be less than. We'll see if there's other words that we add there. So here's the hard one that I was talking about. The temperature is at most 30 degrees. So that's the highest point it can be. The highest point it can be is 30 degrees. So it could be anything less than or equal to that. So the temperature has to be less than or equal to that. So that at most is always less than or equal to. Those keywords like that, that's what gets confusing on these. But we'll.
Sign that confuses me because I always think of the alligator, and I thought the alligator was supposed to eat the bigger one.
The alligator does eat the bigger one. That is correct. As a Florida State fan, that's hard for me to talk about gators, but the 30 is the biggest number that it could possibly be. So the 30 is pointing to the biggest number. It has to be something. T is always going to be something less than that number. So on this one, the books are always going to be greater than 10. So it's more than 10. So that does work. That theory of the gator eating the one will always go towards the bigger one. All right, graph the inequality. X is greater than 3 on a number line. I probably won't write out all my numbers here, but greater than 3. So the rule here is if it's less than or greater than, you do an open circle. You do an open circle. If it's less than or equal to or greater than or equal to, you do a closed circle. That signifies that it does equal that number or it doesn't. Okay, so if it's open, that means it doesn't equal that number. So this is x is greater than 3. So I do an open circle, and it's greater than, so I go to the right. And that's the same way. Like, this is just a visual representation of that. They mean exactly the same thing. So on this one, -2, -3, -1. This one is y is less than or equal to -2. Since it's less than or equal to -2, I do a closed circle, and my arrow is going to go to the left. It's going to go to the smaller numbers. Okay. The way that I remember this, or the way that this kind of cheat code here is, and this only works if your variable's on the left, but like y is less than or equal to -2. This goes to the left. So my graph is going to go to the left. we almost always solve with the variable on the we almost always solve the variable on the left, so that rule will always work if the variable's on the left. So like on this one up here, x is greater than 3, that goes to the right. So my graph goes to the right. And that theory, like I said, that will always work if the variable's on the left. All right, write an inequality for a number line graph showing all the numbers. Oh, so this one in Alex, it will give you something like this. I know we have the answer right there, but I didn't read this before I wrote it, so that's no problem. If I have this right here, if we just have this graph like this, to write that in what inequality notation, we have x, and it's going to the right, so my arrow is going to go to the right. It does equal it because it's closed and it's at 4. So x is greater than or equal to 4. So you can look at the graph and write the equation from it as well. 0, oops, not 0, -2, -1, 0. So on this one, if I have this one right here, so to write this, I would say x, it's going to the left, so my arrow is going to go to the left, and it's just going to be less than because it's an open circle. It's not going to have the equal to part and -1. So that one, they give you the graph and you have to write it out. This one is called a compound inequality. Okay. It says graph the compound inequality 2 is less than x is less than or equal to 6. So 2 is less than x less than or equal to 6. This is x is between 2 and 6. X is between 2 and 6. X cannot equal 2, but x can equal 6, okay? Because x is at 2 less than x is going to be an open circle because it's just less than, and it's going to be a closed circle at 6. And x is somewhere between there. It's not x is somewhere between there. X could be any number between there. So that's where the open and closed circle really comes in handy to know. So on this one, this is saying y is between -3 and 1. Okay, -3 and 1. It is going to be a closed circle at -3 because it's less than or equal to. And it's going to be an open circle at 1, and y could be any number between there. So again, this is saying y is between -3 and 1. Y can equal -3, but y cannot equal 1. So it's some number between -3 and 1. It can equal 1, but it can't equal -3. All right, so that's kind of the going through the different signs and graphing them, different things. When we get into actual equations, everything works the same exact way as solving a normal equation, except there's one catch. The one rule is if you divide, or technically multiply, if you divide or multiply by a negative, you have to flip the sign. Okay, so we'll probably run into this in a little bit, probably not for a few topics, but if you ever divide or multiply by a negative, you have to flip the inequality sign. That's the only rule. Everything else works exactly like it's an equal sign. So to get x by itself, I subtract 4 from both sides, and x is greater than 3. Nothing changes from what we were just doing a minute ago. It doesn't matter if it's less than or greater than or less than or equal to or greater than or equal to. Everything works the same way. It's just if you ever multiply or divide by a negative, you have to flip the sign. So here to get y by itself, I subtract 8, and y is less than or equal to 7. On this one, same idea. I just have to do add 5 to both sides. So I get x is greater than or equal to 7. Nothing is changing about the way we're doing things. That's why we went ahead and did this one today, because it is so similar to the equations. So on this one, to get z by itself, I subtract 3 from both sides. If I owe you $4 and I borrow 3 more, I owe you $7. All right, so we get into one like this where we have to divide. If I divide by 3, I'm dividing by positive 3, so that is x is greater than 4. I don't do anything different. On this one, here I divide by negative 2. That should, as soon as I say it in my head, I'm dividing by a negative. The sign. Divide by negative. Flip the sign.
Wish it would let you go ahead a little bit, with some of your assignments.
Oh, we'll talk about that in a minute. Okay, so you divide by a negative, you flip the sign. One thing I do want to note here, just another problem. If I have 2x is greater than negative 5 or negative 6, let's do. When I divide this one, I'm dividing by positive 2, okay? So it's a negative number divided by a positive. It's what you divide by. So on this one, I do not flip the sign because I'm dividing by positive 2. It's only when you divide by a negative, okay? When you divide by a negative, it flips the sign, okay? There, I'm dividing by positive 2, so it does not flip the sign.
Would it be okay to look at it as, like, since x is a positive number, that it would be greater than, just because it's positive, or would that be wrong to look at it that way?
I'd be careful with that. You mean because, like, this x is positive?
Mm-hmm.
You always want to be careful with thinking about that like that, but yeah, I get what you're saying. X, because like x could be negative 2,
Yeah.
and that's still greater than negative 3.
Yeah.
So, all right, so these, again, just like we've been doing, the only thing you got to watch is if you ever divide by a negative, you got to flip the sign. So to get x by itself, I'm going to move the 5 over by subtracting 5, and then divide by 2 to get x completely by itself. So very, very similar to what we were just doing. You just have that one rule. On this one, shouldn't be any different. I'm going to add 4 to both sides, and I get 3y is greater than or equal to 12. Divide by 3. And y is greater than or equal to 4. Everything is working the same way. It's just if you ever divide by a negative, you have to flip the sign. And what this has, and we talked about plugging in the solution last time, by the way. What this means is you could plug in any number you wanted that's greater than or equal to 4, and it would work, okay? If I plugged in any number I wanted for y, let's just do it. Y is greater than or equal to 4. So if I plugged in y equals 10, that's greater than 4, right? 3 times 10 minus 4 is greater than or equal to 8. So that's 30 minus 4 greater than or equal to 8. Is 26 greater than or equal to 8? Yeah, 26 is bigger than 8. So any number that I pick that is greater than or equal to 4 will work. Okay, that's why it's called a solution set, because any number I pick that's greater than or equal to 4 will work and come out true. All right, just a couple more topics. On this one, negative 3x plus 2 is greater than 8. So on this one, I am going to subtract 2 from both sides. So I get negative 3x is greater than 6. And then I divide by negative 3. Hopefully Alarm bells are going off in your head. You divided by a negative, so I need to flip the sign. Okay? When you divide by a negative, flip the sign. On the next one, I'm going to add 7 to both sides. So I get 4y. If I owe you $3 and give you 7, that means I'm ahead $4. And then divide by 4. So y is less than or equal to 1. Then I think this is the last topic. Yeah, it is. Just like previously, if you have multiple things, simplify the left side, simplify the right side, and then start moving stuff across. So on this one, 5x minus 2x is 3x. Now I've simplified as much as I can on the left because the 3 has an x with it and the 4 doesn't. So now I say, okay, let's solve for x. I'm going to subtract 4 from both sides. So I get 3x is greater than 6. Divide by 3, and x is greater than 2. Let's change that to -7. I'm changing this whole problem real quick. Hold on just a second. That's fine. We'll do that. Okay. -7y minus 3y plus 5 is less than or equal to 15. So again, you see the y's on the 2 y's on both sides. So combine those. -7y minus 3y would be -10y. Now I can start moving stuff across because I've simplified the left-hand side, so I subtract 5 from both sides and divide by -10. Uh-oh, dividing by a negative, flip the sign.
Sorry.
So these you solve just like normal. Unless you ever divide by a negative, you have to flip the sign.